All right, good morning. Welcome back to Calculus. So we're going to look at 7.2 today. These kinds of problems, the ones that you find in 7.2, they are going to be invaluable in helping you get through the class. Okay, at least the first third of it. Okay. So the idea here is that we're going to be dealing with a U substitution. Okay, and one of the things you're going to work with in calculus is every time you make a substitution, you're going to take the derivative of that substitution. Okay, it should be axiomatic, it should be just like the reflex. Okay, so like this one, like you should follow up immediately. So that should be like the substitution, and you should just immediately take the derivative. You may not actually end up using it in the problem. You probably will. But it isn't a guarantee that you're going to use it, but it also is not a guarantee that you're going to make the right substitution. Okay, and that's part of the learning process. So if you're finding yourself not making the right one a couple of times, like you're on the right track. Okay, so it just happens that you need to be able to notice when, like, oh, that does not look like it's going to be going anywhere, and either try a different substitution, or in later chapters you may have to use a different technique. Okay, but you should always, substitution is almost always the direct integration will be your first line of defense here, but failing that, substitution is the next one. Okay, so we have integral here. We have 9 times 9x minus 7 to the 6 dx. Okay, and you see this power here, they're like almost screaming at you, use substitution, because otherwise what we'd have to do to multiply this out, we'd need 9x minus 6 times 9x minus 6 times 9x minus 6 times ... Okay, 6 times, and then we have to FOIL all of this stuff out. Who has time for this? Okay, we're not going to do it that way. That's ridiculous. So what we're going to do is we're going to say, well, why don't we let u equal 9x minus 7, okay, du equals 9 dx. Oh, look, here's one. Okay, so on your worksheets, on people's worksheets, one of the things you may have noticed is, like, please declare your substitution. It's a lot easier to grade them if I see what substitution you made. And also, this is the the most common error that students will have at this point, is to do this. Okay, and then for other reasons, like you might be helping, I mean, we're not seeing each other, but you may be helping somebody else with it. Get in the habit of writing down your substitutions so that people at your level will be able to see what happened. Or, and I seriously doubt you're going to be doing this by hand for any place you would work with, but if you happen to have to sketch something out to help somebody, or to do something like this, get in the habit of writing out your substitutions so other people can follow and see what you've done. Because I mean, I had a manager that she hadn't done math in like 30 years. So, give her the answer. Actually, for her, it didn't matter, because she's just like, I just need the answer. I don't really, I trust you that you were able to get it. But my direct supervisor, he was like, I haven't done this in 30 years either. Could you take me through the steps? So when you're working with things, like they may or may not have believed your technical expertise, but if they didn't, or if they want you to walk them through it, because like, what were your assumptions? What were you doing? It's a good habit to be in. Okay, so I'm just going to ask you, like, please declare your substitutions, let your u and your du go on, so everybody knows what's going on when they're going to be doing this. Okay, so look here, yeah, we got a 9 dx. So we have 9x minus 7. Oh, look, there's 9x minus 7. So we have u to the 6th power, and then we also have a 9 dx out here, so that's our du. Okay. So in this case, you don't have to solve for anything, because you can just borrow from already existing stuff. Just integrate. It's not going to be that big of a deal. It's u to the 7th over 7 plus c. So we just have 1/7. What was u? U is 9x minus 7. That's another reason why you might want to write this stuff down, is that some of these problems get kind of long, and you might have forgotten, like, what did I say u to be again? So yeah, again, it saves us from making those kinds of mistakes. We don't want to make the kind of mistakes where like, well, that was obvious. Like, yeah, now I feel ridiculous. Thanks. Excuse me. So that's pretty much how you're going to be dealing with problems in this section. Okay. So good. Let's see. Do we want to do this one? I think you guys are going to be okay. Let's make the next one. We'll do this one. Okay. So we have a 1 minus t, so integral, right? We have 1 minus t e to the 22t minus 11t squared. Okay. So in this case, this is really this was potentially a chapter 8 problem, but say, well, what's going on here? Right, the thing in the exponent, the thing inside of a square root, those are often a good choice for a u. So why don't we try let u equal 22t minus 11t squared. When I check my du, I've got 22t minus 2 times 11, 22. Oops, that's not a t down there. That is, let's get rid of this. 22, because we're taking a derivative, remember, minus 22t. And this is equal to 22 times 1 minus t. If only we had a 1 minus t in our problems. Oh, wait, we do. Okay, oh, there's a dt here. So what we're going to do is equals du. I'll do it the way the book does it today. That's fine. Okay, there's multiple ways to go about this. But my dt is equal to du over 22 times 1 minus t. Okay, so when we go to substitute, we're going to have 1 minus t, okay, e to the u, okay, and my du is equal to, or my dt rather, is equal to du over 22 times 1 minus t. Okay, this whole thing is my dt here. Notice the 1 minus t's, those are going to cancel. And since this is all times, we're just going to go ahead and slide the 1 over 22 off in front of the integral. Okay, and we have e to the u du, and that's today's integral. So we have 1 over 22, e to the u plus c. And then go back and say, well, this is 1 over 22. E to the what the heck was u? U was 22t minus 11t squared, and then plus c, and we are set. Okay, so it's not so bad. Okay, a lot of these are going to be like suspiciously similar to each other, and that's how you tell that what's going on here. Okay, so let's see here. That was question 3. What's the question 4 says? Okay, we'll do question 4 because I know this one gives you guys, a lot of people have a tough time with this one, or problems that look like this. It's integral of e to the 8th square root of t divided by the square root of t dt. Okay, so again, whatever's up in the exponent, that's a good choice. It's not always going to be the case, but it is a good choice. So we're going to say u is equal to 8t to the 1/2 power. Why did I do it that way? It's because I'm going to take a derivative. So this is 8t to the negative 1/2, right? 1/2 minus 1, and then this comes down in front. So we have negative 1/2 here. Okay. And let's see, we're going to get negative 4. 8 divided by 2 is 4t to the negative 1/2 dt. So that's my du. So we'll say du is equal to negative 4t to the negative 1/2. And then we'll solve for dt. So we have t to the positive 1/2, right? Because we're multiplying both sides by t to the 1/2. Okay. We have a negative 1/4 here. Du is equal to dt. Okay. Now we're going to go ahead and substitute everything here. We have integral e to the what? E to the u. Okay, we have a square root of t here. And my dt, what is dt now? dt is negative 1/4 t to the 1/2 power. D. Okay, so it's kind of nice that these are going to cancel. Okay, so we're just left with negative 1/4 integral e to the u du. It's a nice easy integral. That's negative 1/4 e to the u plus c. Okay, so we have negative 1/4 e to the u. The heck is u? U is 8 t to the 1/2. 8 t to the 1/2 power, or square root of t, either way. Okay, plus c, and that is going to be our integral here. Okay, so that's what we have there. Let me double check my sign here. I think when I take my derivative, this was 8 times 1/2 t to the 1/2. So let me go back and change my mind here, because this was 4t to the 1/2. So I think that's a positive. It's a positive. These are positives, positive, and then finally positive. Okay, that looks a little bit better to me. Okay, so that's, and we could rewrite this. We could also say this is 1/4 e to the 8 root t again, plus c. Okay, both would be fine. All right. So be careful with those. Okay, a little tricky, but not too bad. Let's see which problem was this. This was question 4. 7. Okay, find a substitution to find an indefinite integral. Okay, well, here's one that might be a little tricky. So here's 2u, and then we have square root u minus 9. The issue is that the u minus 9, we can't integrate that from where it is. Okay, because we can't integrate top and bottom independently. We got to deal with it at the same time. Okay, so you might say something like let u is equal to, oh, we're already using u, sorry. Favorite letter after that. Okay, so how about u and v look too much alike. Let w equal u minus 9. So dw is equal to du. Right, and that's not gonna help too much. Okay, we have to massage this thing. Okay, so when I go here, right, we have integral, we have w to negative 1/2 power. What am I supposed to do with this? du is just dw, and I'm stuck with a 2u here. You can't do this. You have to have the same variable in both spots. All right. So what I'm going to do here is I'm going to say, well, let's force the issue here. Let's have w plus 9 is equal to u. All right. All I did was add 9 to both sides. So now I've got 2u, but u is w plus 9. And I'm going to say this is w, should be just 1/2 to the negative 1/2 integral dw. Okay, so how that happened was the du was dw, so that doesn't change. The u to the 1/2 turns into a, or sorry, w to the 1/2 turns into a w to the negative 1/2. Then I've got this. Now, since this is not all within a square root, right? We don't have a plus sign inside of a square root. We have just a term inside of a square root. We can multiply this. Okay, so this is going to be 2w. It's the same base, right? So what do we do when we have the same base? We add the exponents. So this is 1 minus 1/2. So this is w to the 1/2 power plus 9w to the negative 1/2. notice that this exponent on the w plus 9 is just a 1. So we can multiply through like that. Okay, and then we have dw. So now we could just go ahead and say, well, this is 2. Okay, and then this is going to be w 1/2 plus 1. That's going to be 3/2 times 2/3. Okay, plus 9. And then we're going to have integrating here. So negative 1/2 plus 1, that's going to be 1/2 divided by 1/2 plus c. Okay, so we're going to have 2 times 2/3 w to the 3/2 plus 18 w to the 1/2 plus c. So to finish this guy off, we're going to have 4/3 w to the 3/2 plus 2 times 18 is 36 w to the 1/2 c, and that's going to be our answer for this thing. Okay. Be careful about these. Your book rather likes these, and I kind of like these too. So if you're looking at this and you're like, I'm not really sure this is going to end up, and this didn't look like it got me too far, try to rearrange some terms and see if you can't force it to fit into there. Okay, so trying to make sure that that's going to work. Okay, sometimes it doesn't. Sometimes you might have to try something else. Okay, so I'm just warning you that just because you picked a U or W doesn't mean that that's the one that's going to work for you. Okay, you might have to do some trial and error and pick a different one. Okay. So let's see here. Yeah, this will go. Okay, so again, this kind of piece here, this is kind of screaming at us. Hey, let whatever's inside its power be a U. All right. Because we really don't want to multiply all of this out. Okay, so we have integral of 3 plus 2 ln x all raised to the 5th power. Looks delightful, doesn't it? If I had to multiply that out. So what we're going to do is we're going to let u equals 3 plus 2 ln x. It's inside of the power. I don't want to multiply it out. That's your choice. Okay, in general, that's your choice. Du is equal to, well, constants are 0. So we have 2. You know, what's the derivative of natural log x? That's 1 over x. Okay, dx. So what we're going to have here is dx is equal to x times du all over 2. Okay, that's my dx. So what I'm going to do is I'm just going to substitute where I can. So this is 3 plus 2. Actually, that's u, isn't it? Because we said 3 plus 2 log x. That was now going to be u. So we have u raised to the 5th here, divided by x. And my dx is going to be x du over 2. Okay? So the x's here, these are going to cancel because they're all times. Okay, so we have integral of u to the 5th. Here's my du. And this 1/2, what do I do with that? Well, that comes out to the front of the integral because this is all times. Okay, if there's a plus, you can't do it, but it's times, you can do this. And now we just integrate as normal. This is u to the 6th over 6 plus c. 2 times 6 is 12. So we have 1/12. U to the 6th, what the heck was u again? U was 3 plus 2 log x to the 6th power plus c. So be a little bit careful, but if you see a natural log somewhere and there's an x on the denominator or something, it's a good choice, that a good chance that natural log is going to be part of your thing there. But again, make sure that all the x's are accounted for. You've changed all the x's back into u's, so you can go ahead and integrate. All right. And let's see here. That was question 8. How about question 10? Okay, so an epidemic is growing in a region at a rate of, remember it's a rate, so this is a derivative, n tick, and the derivative of n is equal to 70t divided by t squared plus 3. N is the number of people who are infected after t days. I wonder what that would have any practical or real application to these days. So find a formula for the number of people infected after t days, given that 49 people were infected when we detected the disease. Okay. And then use this answer to find the number of people infected after 27 days. All right, that's not going to be so bad. Okay. So again, I don't like this denominator. That's usually a problem. So why don't we go ahead and say, we have to integrate n tick. Okay, we have to integrate this derivative here. So we're going to say this is the integral of 70t divided by t squared plus 3. I can't factor the denominator, so that throws the one we did on the worksheet out. Okay, we're kind of stuck with, well, why don't we deal with this denominator and hope for the best? Okay, so let's let u equal t squared plus 3. Okay, du is equal to 2t dt. So dt is equal to du over 2t. Okay, just solving for dt here. Now let's see what happens. All right. So we have integral of 70t divided by t squared plus 3. That's our u, right? And our dt here, this is a du over a 2t. Okay. So because these t's will cancel, we've got a pretty good idea that we're in the right direction here. Because you don't want t's and u's at the same time. And this 2 and the 70 is going to turn into a 35. Okay. So let's go ahead and finish this one off. So we have 35 du over u. Let's put the 35 out in front. So we have 35, 1 over u du. That's how I memorized it. Okay, and that gives us the natural log. So this is 35 natural log of u, okay, plus c. Now in this case, what is the problem about? Okay, the problem about is t is equal to the number of t after t days. Well, it is possible we could have negative days that just happen before the start. That's okay. But I don't think they're going to do that to us. I think an epidemic, the reason t equals 0 is the first day. I don't think we need the absolute values here so much. Okay, so what we're going to do is we're just going to hit 35 ln. What was my u? My u was t squared plus 3. And t squared plus 3 is always going to be positive anyway. If you remember your college algebra, right? What's t squared plus 3 look like? It's a parabola of a vertical shift of 3. So even though we can pick negative t's, we won't, but all the values are going to be positive, so we don't really need some absolute values there. Okay. So what else information did they give us? They said find a formula for the people infected t day after t days, given that 49 people were infected on the day 1. Okay, so this would be y or n when t is equal to 0. Okay, y was equal to 21, I believe. 49. Okay, so what we're going to do here is we're going to say y is equal to 35 times the natural log of, you can put in the 0 squared. Yeah, I'm just doing it to show you what's going on. Plus 3 plus c, and this is equal to 49. Okay, so this looks like a delightful amount here. So we've got 49 equal to 35. 0 squared is 0. So we have natural log of 3 here, plus c. C is equal to 49 divided by 35, natural log of 3. And you know, there's, what's 35? Isn't it 5 times 7? 49 is 7 times 7. So that'll cancel. So we got 7 over 5 natural log 3 is equal to c. So our function n is equal to 35 natural log t squared plus 3 plus, what's c? 7 over 5 ln 3. Okay. And what are we doing with this? We're saying after 27 days. So we're going to put in our 27 here. Okay, plus 7 over 5 natural log 3. And I guess round to the nearest integer. Round down, I guess. Nearest integer. Okay. So that would be something that you would do there. You might have to round up. Okay, by the way, my math lab they're very picky. Okay, so be careful about what you're putting in there, but if you get it wrong or something, then, round to 3 decimal places, that's fine. Okay, so we'll just do it that way. Okay, they're okay with 3 decimal places worth of people, that's fine. Okay, so there we go. That's how you do something like that. Don't be intimidated by this thing, but that's where we are. Okay, I think that's about it. Good, 10 problems, that's appropriate. Okay, so good luck with that. Again, things to pay attention to. If you have an e to something, whatever this thing is, that's probably your u equals that thing. If you have a function that is, whatever the bottom is, it's difficult, that's probably a good choice for u equals. If you have a logarithm of something, at least in this chapter, okay, u is going to be whatever's inside the logarithm. Square root, same thing. Okay, square root of something, u equals that something. Okay, I'm not going to say it's going to happen that way every single time, but those are good bets. That's what I would start with. If that failed, I have to re-examine it and look at it, and maybe the whole natural log is going to be that. Okay, rather than just the argument, or maybe the whole square root is going to be that, rather than just the square root. And then again, be careful with functions that we have like a y minus 3, and then, or a y, and then square root like y minus 6 or something. That's going to be one of those cases where you're going to have to recast this. You're going to say let u equals y minus 6, du equals dy. You might have to do something like u plus 6 equals y to substitute back as well. Okay, so be careful with that. Again, don't think that just because you picked a u, that has to be the answer. Okay, everybody picks the wrong u sometimes. Be aware enough that you may have picked the wrong one, and you're allowed to pick a different one and start back at the beginning again. Okay, it's not always going to be, I always pick the right one. Okay, that's not true. All right, so I wish you luck with 7.2. The better you could do in this section, the better you're going to be in the whole class, because this U substitution business is going to keep coming back up. All right, so I will see you in the next video, and good luck.